Let's solve a system of equations using matrices. We have the 3 by 3 system, and the first thing that we're going to do with these 3 equations and 3 variables is to create an augmented matrix. So we'll just write the coefficients. I'll write them in columns. So the coefficients on x are 1, 2, and negative 2. The coefficients of y are 2, negative 4, and 2, and the coefficients of z are negative 1, 1, and negative 3. And we draw a line for our equal sign, and on the right hand side the constants are negative 3, negative 7, and 4. Now we'll be performing some operations on this matrix so that we can solve the system of equations. Before I perform the operations on the matrix, let's go through the steps that we'd like to do. With the 3 equations and 3 variables, what we would like to do is first of all to get a 1 in row 1 and column 1. So we want this element to be a 1, and we can see that it already is, so we're off to a good start. After we get this first element in row 1 and column 1 to be a 1, we want to get zeros underneath it. And then along the main diagonal, our next step will be to get a 1 along the main diagonal, followed by a 0 underneath that. And then our next step will be, again, to get a 1 along the main diagonal. And really, these other elements does not matter whether they're 1s, 0s, or any other number. They'll be whatever they're going to be. And then on the right-hand side, we'll have some numbers. So this is the process that we're going to go through in order to solve this system. And we'll do this on the next page. So I've written the matrix down here, and we're going to start by making sure that our first element in row 1, column 1 is a 1, and it is. So we're off to a good start. Now we need to get zeros underneath it, and we're going to make sure that we use this 1 in row 1 to help us. If we multiply every element in row 1 by negative 2, that can help us, because if I take negative 2 and I add it to positive 2, that will give me a 0 here. So that's what I'm going to do. I'm going to multiply row 1 by negative 2, and I'm going to add it to row 2. And I'll write that down right here. I'm going to take negative 2 times row 1, and I'll add it to row 2. And I'm putting it right here by row 2 because that's the only row that I'm changing right now. So I'm going to rewrite row 1 as 1, 2, negative 1, negative 3. And we're now going to multiply row 1 by negative 2 and add it to row 2. So here we go. Negative 2 times 1 is negative 2, plus 2 gives me 0. Negative 2 times 2 is negative 4, plus negative 4 gives me negative 8. Negative 2 times negative 1 is positive 2, plus 1 gives me 3. Negative 2 times negative 3 gives me positive 6, plus negative 7 gives me negative 1. Now we're going to do a similar type of operation for row 3. But in this case, notice in row 3 we have a negative 2. We want to get that to be a 0. So what we'll do this time is we'll multiply row 1 by positive 2, and we'll add it to row 3. Because if we do that, positive 2 times 1 is 2, plus negative 2 will give me 0. So I'll write that operation down. We'll take 2 times row 1 plus row 3, and that will be our new row 3. So here we go. 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4, plus 2 is 6. 2 times negative 1 is negative 2, plus negative 3 is negative 5. 2 times negative 3 is negative 6, plus 4 is negative 2. So far we've gotten a 1 in row 1, column 1, followed by zeros underneath. our next step, remember, is to go along this main diagonal where I have -8, and I want to change that into a 1. So we can use one of our 3 row operations. So I'm going to just rewrite row 1. And if you recall, one of the things that we can do to any row is multiply each element through by any non-zero number. So the non-zero number we want to multiply through by would be the reciprocal of -8. In other words, that would be -1/8. So we want to take -1/8 and multiply it through row 2. When we do that, we'll have 0 times -1/8 is still 0. -1/8 times -8 gives me +1. -1/8 times 3 gives me -3/8. -1/8 times -1 gives me +1/8. Now, I'm just going to rewrite row 3. I have 0, 6, -5, -2. My next step, now that I've gotten my second one along the diagonal, is to get a 0 underneath it. So in this case, I'm going to write down the first 2 rows because they won't be changing. Only the third row will change this time. So I have 1, 2, -1, -3, 0, 1, -3/8, 1/8. And in order to get a 0 in the place of this 6, I'll need to use the 1 right above it to help. And I'll take the entire row 2 and I'll multiply it by -6 and I'll add it to row 3 to get me a 0. So I'll write that down. I'm going to take -6 times row 2 and I'll add that to row 3. So here we go. -6 times 0 is 0, plus 0 is 0. -6 times 1 is -6, plus 6 is 0. -6 times -3/8 is positive 18/8, plus -5 gives me -11/4. If you need to do a little bit of calculation on the side, that's okay. And -6 times 1/8 is -6/8, plus -2 gives me -11/4. Now the last step is to get a number +1 where I see the -11/4 along the main diagonal. And we can do that by simply multiplying each element in row 3 by the reciprocal of -11/4, which is -4/11. So I'm going to rewrite my system, and I'm not going to change the first 2 rows. And I'll have 1, 2, -1, -3. Then I'll have 0, 1, -3/8, 1/8. And in row 3, we decided we're going to multiply the entire row by -4/11. And when we do that, -4/11 times 0 is still 0. -4/11 times 0 is 0. -4/11 times -11/4 is +1. And again, -4/11 times -11/4 is +1. Now we're ready to start writing down the solution. What we have on this bottom row really says 0 times x plus 0 times y plus 1z equals 1. Remember, the augmented matrix is just a shorthand way of writing the system of equations. So we'll start with this bottom row, and really, do you see in row 3, we have the statement that z is equal to 1. Now we're going to use back substitution to find y, and back substitution again to find x. So my second row really says 0 times x plus 1 times y minus 3/8 times z is equal to 1/8. I can substitute 1 in for z, and I'll have y minus 3/8 times 1 is equal to 1/8. If I add 3/8 to both sides of this equation, I'll get y is equal to 1/8 plus 3/8, which is just 4/8, or 1/2. So now I've found z and y, and I'll back substitute into my first row to get x. The first row says 1x, or just x, plus 2y minus 1z equals -3. I'll substitute in what I know y and z to be, and I'll have x plus 2 times y, which is 1/2, minus 1 times z, which is 1, equals -3. If I solve this equation for x, I just get the solution that x is equal to -3. So now I can state my solution. The solution set is the ordered triple where x is -3, y is 1/2, and z is equal to 1.